Anna, thank you so much for joining me today.
Thank you for having me, Pratik. I'm looking forward to it.
First of all, AI infrastructure. It's a massive topic. It's becoming extremely important. And as we train bigger and bigger models, it's becoming only more critical. So from your perspective, just an infra 101, what is the single hardest engineering problem that people are trying to solve with like large scale model training today?
So one of the things that is not really unique to AI, but just general infrastructure is how do you make something work on thousands of machines? How do you make it work so that it's about as fast as it was on two machines? I mean, there is going to be some slowdown, but what you're looking for is to be as efficient and fast as it can be, and still be at the scale that you need it to be.
And in terms of the budget, basically, if you're looking at all the line items, data, networking,
Mhm.
ops, modeling, where is most of the budget going at this point?
Yeah, I think that has been shifting over the last 12 months. I think when you look at publicly available data, which there isn't that much, I think a year ago, OpenAI said that, their budget for training and inference, that training was a little bit less than half. But as their traffic has, grown, then a bigger budget item than training. So, people kind of disagree on what that steady state looks like. Is it going to be 10% of the overall spend? Is it going to be 20%? But definitely, we don't think it's going to be 50%.
Right. And let's move to just looking at the state of play. So, if you were teaching or explaining the AI infra landscape to somebody who's new to this, how would you explain that? Like, what are the layers we're looking at? And also, where is the opportunity? Where is it oversaturated? And just what does it look like overall?
Yeah, I think, overall, a lot of people, kind of only look at two phases because they're in the news all the time. There's the very bottom, which you might want to call NVIDIA GPUs, but those actually fit inside boxes. They fit with memory, and then they fit in data centers. And you'll see like CoreWeave went public recently as a data center that had. And then there is infrastructure that a data center would use in order to keep track of like the sickness or health of their machines. If all the connections are working perfectly. And then there's the software on top of that that does training or does inference. And then you'll see some companies like Fairworks and Together um, have inference endpoints over NVIDIA GPUs and usually public open source models. And then you'll have your model layer, which can be open source models from Meta, DeepSeek, Quinn. We're having a great time with Quinn models these days. They're
Right.
pretty amazing. And
Yeah.
on the other side, you'll have Anthropic and OpenAI, and of course, the Gemini models.
Do you expect verticalized infrastructure like vision only or text only or video only to win over general purpose clouds? Or will there be some kind of balance or will there be an 80 split? Like, how do you think this will play out in the next 5 years?
I guess I see that at the end of 5 years, we probably won't be making that distinction. I think when you look at that evolution, yes, maybe people went to YouTube to get videos, and they went to image search to get images, and they went to Google search to get text. But then you would do a search and kind of get the right answer for you. And then behind the scenes, the various systems that were better at that modality or better at understanding that query kind of came to bear and kind of gave you the right answer. So I'm not saying under the hood there won't be an image only model, but I'm saying that from the user perspective, You ask something that's answered in text, it'll be answered in text. You ask something that is better answered with an image, and it'll be answered with an image. There could be a very specific model that was good at just that. But from the user perspective, I think they just won't be thinking about it.
That's amazing, because what you're saying is if you want internally, you can verticalize all you want, but
Yes.
abstract it away because the users, they don't care. They just want to
Yeah.
come in to one
Yeah.
shop and kind of get all their problems solved, and they don't want to stitch like 17 different little
Yeah.
tools, right? So, okay. Okay. Fair
That's how
point.
I see it evolving for sure.
Right, right. Okay, so let's go to the launch of Ceramic. So
Yeah.
now, right before the launch, and when you looked at, you've been in infra for a long time. Obviously, you're a lone builder. So, what convinced you that something here needs to be rebuilt from scratch, especially the training stack? And
Yeah.
also, what functionality did you decide to ship in the MVP? Like, how did you decide that?
Yeah. I think that when we looked at the open source offerings and the current stack, it was really highly nimble. It contained a lot of experiments that maybe famous researchers had run, but it was written in a world where people weren't sure kind of what the winning architecture was going to be like. And so I think that the world more coalesced around a Transformers plus plus architecture. And when you look at the differences between, let's say, a Llama model and a Gemma model, the Gemma adds, a few layers of norming over a Lambda model. It's just in general, the differences became smaller. So at the beginning, I guess the world wasn't sure what way it was going to go. And when they're coalescing around a Transformers plus plus architecture, that's a time when you say, okay, well, maybe now you can simplify it. Maybe now you can make it go faster. And then, the other kind of pieces that existed now that didn't at the beginning was more of an understanding that, long context training needed to be more of a thing. So those are the kind of general principles that we went for. It's hard to make something with 11 cup holders also go fast. So, so we were like, okay, let's think about, simplicity and efficiency.
Right. And if you think back, how did you decide what to leave out of the MVP? Or rather, like when you're guiding a younger builder, like how do you tell them, hey, this is a framework to use to decide what goes in and what goes out of the MVP?
Yeah, I mean, I think you mentioned it a little before when you said, 80/20 rule. I think if you're going to build something, kind of needs to have an opinion. If you wanted to put in absolutely every experiment that is, in the open source stack and do all the things that, that you can do, have like maximum flexibility, um, then you might as well use that. But we'd heard a lot about how people had, it was a cognitive load to understand all those bells and whistles, 67 variables to call the train function. 5 of them are about FP8s. And those 5 have to be set just right. Otherwise, it won't work. And it's kind of just a trap for the unwary. So it's like, sure, for experts, maybe you want, 2 levels, you want FP8 on or off. And then if you're an expert, maybe you can set those 5 variables. But it's just that's not the state of most people.
It's a great framework. Going into when I was going through Ceramic, the 2.5x speed up was caught my eye, and in this case, when everyone's rushing towards it, achieving any kind of speed up is difficult. So 2.5x. Can you talk about what you had to do to achieve that, and also where is it coming from in terms of
Yeah, I
the
guess
stack?
we like to be very, we like to have everything be very reproducible and to caveat exactly where that is. And so that's why we give a table to say that for long context training, it's 2.5x. And then how we achieve that is by laying out the computation a little bit differently. So I think one of the first things that you learn if you've ever done any data mining, you learn that you move the algorithm to the data, not the data to the algorithm.
Yep.
And so we kind of used principles like that in order to break up the computation a little bit differently. And so by using a version of context parallelism that gets along with flash attention, and by laying out the computation differently on the GPUs, then that's how we achieve the speed up.
Right. And there has been a strong focus on long context in our discussion. So I'd love to maybe quickly, for people who may not know, can you
Okay.
explain short, medium, and long context
Sure.
and the trade-offs between those?
Yeah. I guess a short context is 1 to 2K. I think the very old models trained on a 2K context, and a 2K context is about 4 pages of text. But if you were processing web text, it really depends on how people have pre-processed the data. It could be as easy as thinking about it as 4 pages, but if you're processing all of, the scripts and everything on the page, if you do it wrong, then you're really processing a tweet. So I kind of think of it as that, training a short context is sort of like learning from tweets or very short pieces of information, or learning from user generated comments, of any kind. It's a short amount of data. It does contain things, but in general, that's not the way humans learn. We learn more from textbooks, which are definitely a long context. And even then, if you've ever taken a sequence of math classes, yes, your professor expects you to remember stuff from previous books. So that's more like long context learning. And then in the middle is more like learning from academic papers, definitely meatier than a short form, but not as meaty as let's say a textbook.
Amazing. I love that explanation. It's nice and easy to understand. Now, with long context becoming more and more prevalent and models are getting better, can you maybe not contrast, but just compare it to RAG, retrieval-augmented
Yeah.
generation, and see like if we get better at long context, where is its place as compared to RAG systems? Will it be a combo? Will one dominate the other? How do you think this
You can't
play out?
ask a search person about RAG, right? So I guess me, the RAG has a few things that are a bit of an anathema for search folks. One of them is if you were to have a terabyte of data, RAG turns it into 10 terabytes. I mean,
Right, right.
whereas search takes a terabyte of data and turns it into about a terabyte of index. Secondly, search is more like, if you understand algorithms, it's almost more like a hash table.
Hmm.
It's very fast to retrieve. And RAG does linear retrieval.
Hmm.
It's actually going to go like maybe you would search your spreadsheet of
Right,
upcoming people you're having a chat with. Maybe you
right,
just go down the line. Oh, when am I chatting with Anna?
right,
And so for search people, RAG is interesting.
right,
And so what we're talking about is context for training, and RAG is generally adding to the context at inference time.
right, right. And when you think about the real world systems that are being built, if we get better at long context, where will its impact be the highest? Like today, it's not good, but with long context getting better, it'll be much better. Is it medical? Is it legal? Is it something else?
I think it is, it will really help the remembering part of large language models. It's going to help, reduce hallucinations. People think it's going to help reasoning. So generally, I think it will help across the board, but I think reasoning, is helpful for legal. Remembering things is good. Pharmaceutical companies, also in banking. So people generally think it's a good thing. I'm gonna have to leave it to all the robo practitioners for all the things they like it for. because people always say code as well. So yeah.
Right. Um, and also on your website, you've mentioned that you can train models on 96,000 words at once, which we were just talking about, long
Yeah.
context, without loss of performance. Now, at that scale, when you go from 1,000 words to 96,000 words, along the way, like what bottlenecks appear at that scale? And also, as you're doing more research, maybe you'll increase this even more. So, what bottlenecks are you facing as you're scaling this up?
Yeah, I mean, the longer the context is, the more important the attention mechanism is because you're spending more time in attention. So there you kind of leave it to the people who really optimize attention. TriDAO does flash attention. NVIDIA, I think, was the releaser of the latest dot product attention that works really well. So, but yes, the longer the context, the more time you spend in attention, and that starts to dominate. And so that becomes a bottleneck.
I want to move the topic to data, especially as data sets keep getting bigger and bigger. Figuring out how to prune it becomes very important because you can't just keep throwing compute at it. So, as a baseline, how do you decide what percent of tokens are actually hurting convergence and must be dropped
Mhm.
versus what needs to go in? Like, how does that happen? But like 101.
Yeah, I mean, we actually wrote a blog about it recently, mostly, um, echoing pieces that other people have discovered. I think that one of the things people note where they keep training from the web is that it over indexes on, let's say, celebrity gossip.
Right,
So, like, too big a percentage of the web is on that
right.
compared to the queries. So you kind of look at content that's very repetitive, doesn't kind of add anything new semantically. And then if you do think about, okay, I'm going to converge this down to like one semantic notion, celebrity A got a divorce from celebrity B. There might be thousands and thousands of articles, but there's kind of only one fact. And then also look at the queries. Like there's like a mismatch between the amount of content and then the queries for that content. That gives you a good proxy for what you should be deleting, what you should be making less of. And then you want to promote high quality content inside training because um, it learns better. So when I was making my argument about tweets earlier, like even how you put together the context for training matters. If you put together context all about different topics that are all very, very short. So let's say you make a 96,000 context, but out of little short pieces, all this user generated content, it's not going to be on one topic. It's going to be hard to learn across it. And so that's something that you have to think about as well. What's the size of your context? And what's the size of the model you're going to be building? And I guess something that I don't see a lot of people talk about is what do you want it to be good at, right? I mean, if you want it to be good at math, a lot of people say, okay, it needs to have more math, but there are, a certain amount of documents that you need just to teach the machine kind of how to think, how to react, how to form answers, how to break down problems.
There are domains where the ground truth is obvious, like trivially true. Like 2 plus 3 is always 5. It's not open to interpretation. But in domains where the ground truth is not obvious, like could be legal advice or some subjective
Yeah.
area,
Yeah.
how do you define better data? Like what's good data, what's bad data here?
Well, I mean, luckily, legal has a lot of good data because, they have their case law, they have amazing data inside LexisNexis, like things that they use to search. So they have amazing data. But I would say let's go to the other side. Like, how do you train these reasoning models? It's usually a post-training step. And there, if you would say, guilty or not guilty, or even in logic, true or false, so the whole reasoning is right if you answered true? No. That's like a 50-50 coin toss, or it's 50-50, let's say, guilty or innocent. And so just because the answer is right, you can't say that the reasoning is right. And that's why you have to use other techniques other than correct and incorrect to push back actually grading the reasoning. And so that needs other techniques that are just emerging and just being worked on now.
That is a fascinating point because many times, at least historically, machine learning has always been, hey, did it identify the thing correctly? Yes or no? Yes, you get a reward. No, you get penalized. But reasoning opens up a whole new paradigm. So maybe I want to double click on that for a second. Just in simple terms, how do you grade reasoning? Like how do you figure out, hey, this machine, two machines arrived at the same answer, but the reasoning on machine A was wrong and reasoning on machine B was right, or rather I want to encourage B and not encourage one. Like how do you grade
I
reasoning?
mean, I see some people firing up theorem provers. That is quite difficult. One of the things that you can do is see whether one statement logically follows from another without saying, hey, this whole thing has to fit perfectly in a theorem prover. And you can say how many of the steps were logical or not logical, but you don't want to um, have like longer reasoning things all of a sudden, be deemed to be better because they had more things that logically followed. Generally, you'll have to learn a preference rather than just saying right, wrong. You'll have to learn a preference. Unfortunately, that's going to be a combination of both something that's maybe mechanistic, whether things follow from each other, and others that are graded or some sort of preference.
Right. Amazing. Now, moving on to synthetic data. So, starting point, like, what's your view on synthetic data as the starting point?
Synthetic data, great. I'm pro synthetic data. Yeah, if that's the starting point. Yeah.
That's great. Now, when you look at all the new models being built, if you compare the performance of synthetic data sets versus human curated data sets, like where is it today and where will the future be? Will we be reliably able to use only synthetic data to build amazing models, or will we still need human curated data or a combo?
I mean, I think it's going to be definitely the majority is going to be synthetic data. Will there be no human data? No, I don't think there's going to be no human data. It's just that the availability of human data, like take the common crawl. The common crawl has been crawling maybe 16 years. Pretend is 15 years. I'm not exactly sure how long, but that means that they can't just generate double the data overnight, right? It's taken them 15 years to collect this amount of data. They can't make it bigger. They can't double it this month or this year. It's not possible. And that's kind of the kind of case where synthetic data comes in. I saw a recent talk about synthetic data for robots in that, a robot can only last so long walking around in the world. There's power limitations. For the robot, there's human attention limitations as well. But with synthetic data, capturing that environment and putting in more data is quite feasible.
And when you look at fast moving fields like cybersecurity or something else that moves really, really fast and you have to keep up, uh, i- can active learning loops or some other mechanism, can we realistically keep up with these knowledge domains where you instantly become obsolete or almost semi-instantaneously? So how do you think about that?
Yeah, I mean, I definitely think that is an area of active development. Like, how do you make these large language models stay current? I mean, you'll see that before the last Anthropic release, if you searched for something kind of newsy, they said, I don't know anything after October of 2024, in case you're asking me about something current. And so that's not particularly fast moving. That's, just kind of up to date. So they did release a new model, but that is a weakness of current approaches. And there are a lot of people working on how to keep large language models more current.
Now, as we look forward, more and more large companies are testing AI, they're experimenting with AI, and soon enough, it'll be part of their daily lives. So, in 5 years, does every enterprise maintain its own little domain specific, company specific foundation model, or do we do we collapse into, not collapse, but do you have a handful of hyperscale providers who do all of it infra? Because it's hard, it's hard work. So how do you see like Walmart and Procter and Gamble, like how will they embrace some AI?
I mean, they have definitely their own data, whether or not they make a little model to the side themselves or whether they ask Anthropic to make them a data to the side that they answer together with the Anthropic model to answer Walmart's question. Or maybe Walmart's using OpenAI. It's really for Gemini, whichever they're using. I see that they will need to use their own data so that the large language model kind of speaks their language. But do they actually need their own model, or will the model be able to be further trained, like on Walmart data, in order to speak Walmart? And then you have a combination system that ingests the rest of Walmart data. I think that the infrastructure here is really flexible, and I'm really not sure which way it's going to go. But I think that my best guess is neither of those. Sorry.
And as you think about what can unlock a 10x gain, network topology, maybe memory hierarchies or something else. So if you look at the infra layers today, where can we unlock the next gains?
Yeah, I mean, one of the things that when people are saying, okay, there's no more data, so we can't make a model 10x bigger. And, is a model 10x bigger going to be like that next generation better? I definitely think people are going to push that boundary. And like you said before, they're going to push it by adding more data that is synthetic. And, have previous generations, have they, cut out certain information that now they're going to bring back in order to have more data? I think that's a possibility as well. But it starts to get into like physical limitations. Okay, are you going to need a 10x bigger cluster, or are you going to have to train for 10x longer? And so those meet like some real world demands. And if you're going to make something work on a very, very large cluster, and you do that by um, you know, updating like how many tokens you train on before you take a step, is that actually going to make a significantly better model? Or would you be better off training for longer, a bit less data? I think all those experiments are probably being run right now to the tune of billions of dollars. Yeah.
Right, right. I have one final question before we go to the
Yeah.
rapid fire round. And
Okay.
this is about just the advancements that are happening. So, to you personally, what AI advancements are you most excited about?
What AI advancements? Yeah. I guess that I mean, I'm really excited for this time. I have lived through AI winters before, and I think that, I almost think of, ChatGPT only came out, whatever, a little over 2 years ago. So, I'm still very, very excited about large language models, and, want to work on like removing limitations around like why people aren't using them for tasks. Like what are the shortcomings now, and how we can make them better.
Amazing. With that, we are at the rapid fire round. I'll ask a series of questions and would love
Okay.
to hear your answers, 15 seconds or less. You ready?
Okay.
All right.
I'm ready.
Question number one. What's your favorite book?
Well, my favorite book is whatever book I'm reading with my daughters. So I have 4 kids. I have a son and then 3 daughters. And the daughters and I have a book club. It started out with me reading a book to see if it was appropriate, and then it turned into a book club. So, of course, we, like many other people, read the Fourth Wing series recently.
Amazing. That's great. So, yeah, I think more than adult books, I'm reading kids with I have 2 kids, so the same thing. I think that's a very good framework because in that
I
moment,
know
it's a great.
most people don't talk about reading for fun, and I actually answered that on like on a live panel. A lot of people reached out to me and said, "Oh, like thank you for humanizing like reading for fun." And I'm like, "Isn't that most of the reading that we do is
Right.
hope is reading for fun?"
Oh, that's so good. No, that's brilliant. I think it's all these episodes, the most unique answer about this question that I've gotten. It's just amazing. All right, next question. Which historical figure do you admire the most and why?
Yeah, I guess this is, probably a lot of people have answered this, but I have great admiration for Stephen Hawking. I think not only did he invent things that were really a little bit unpopular at the time, like, oh, you have that stance on your subject. That's not really the received wisdom. But I think, of course, he had great physical challenges to overcome while contributing to the field. And I just have a lot of admiration for that and his spirit. He hosted famously a time traveler party. Do you know about this?
No,
He
I don't.
sent invitations after the date of a party for a lat long and a date. And he said there was going to be champagne and an orchestra, and he was really looking forward to who would attend this party. And of course, he didn't tell the world who attended the party. I guess it was for time travelers. People were interested in time travel like him. So I just thought that also shows like a real, I don't know, a lightness of spirit. I just love that as well.
What has been an important but overlooked AI trend in the last 12 months?
Yeah, I guess one of the AI trends that I see is almost a bifurcation of people who say everything's done and people who say it's just beginning.
Right,
And
right,
so I
right.
think I think that's pretty funny that obviously both of those can't be true. Yeah.
What's the one thing about AI infra that most people don't get?
I would love more people to kind of play around with it themselves. I think people consider maybe like computers hard, etc. So a long time ago I wrote an article called like $5 chatbot, urging people to like understand how to load a model, understand how to LoRa fine tune it, bring up an instance and ask a few questions, trying to demystify that this was something like only computer scientists could do.
What separates great AI products from the merely good ones?
That's probably the same answer for non-AI products. I think whether or not, they solve a problem, whether or not people can use them and hopefully enjoy using them.
What have you changed your mind on recently?
Yeah. I've changed my mind on yeah, what have I changed my mind on recently? Maybe we'll have to come back to that. I'm the kind of person who does change my mind all the time in light of new information.
Right.
I'm not one of those people who is like really stuck on things.
What's your wildest AI prediction for the next 12 months?
For the next 12 months. Oh, okay. In the next 12 months, I think we're going to see more people who want to download themselves so that future generations can interact with them.
Right. All right. Final question. What's your number one advice to founders who are just starting out?
I think, make sure that you're really, really passionate about what you're building. It's like always going to be, there's always going to be hard times. Nothing is going to always go perfectly, but like your intense interest in the subject and your passion for seeing it through is kind of what's going to get you through.
Amazing. Anna, this has been a brilliant episode. I love the way infra is a fairly complex topic. So I love the way you explain things so that it's accessible. So thank you again for coming onto the show and sharing your
Thank you.
insights.
All right. Thanks. Take care.